Hello everybody and welcome back to Unit 11 of Regents Chemistry where we are talking about acids, bases, and salts. Today we will talk about the last topic in this unit, which is titrations. So titration is a lab process in which we take a solution that we know the concentration of, and we use a specific volume of that solution to determine the concentration of another solution by titrating it. So it's basically a practical application of a neutralization process where we have an acid which has hydrogen ions and which is reacting with a base that has hydroxide ions, and both of them react to form water and a salt. The number of moles of the hydrogen ions have to be equal to the number of moles of hydroxide ions so that both of them can combine to make water. And we use indicators in this process that indicate the change from the acid to a neutral solution or from a basic solution to a neutral solution. This is what the apparatus for a titration looks like. So we use a ring stand which has that clamp at the top, and that clamp is holding a burette. The burette has our standardized solution. Standardized solution is the one that we know the concentration of, and because it's in the burette, we can also measure its volume so that we know how much of that standardized solution did we use to titrate our solution with the unknown concentration. So that solution with the unknown concentration is over here at the bottom in the Erlenmeyer flask. And after we put the solution in there, we also put the indicator. And when the indicator changes color, that indicates that now that solution is neutralized. So let's talk about the procedure for a titration experiment. Once again, we see the apparatus here. First of all, we take a flask, an Erlenmeyer flask, and in that flask, we pour our solution that has the unknown concentration. We are trying to find that concentration. But we do know the amount of that solution that we are using. So we know if we are putting 10 milliliters or 20 milliliters or whatever amount of that solution into that flask. And then we also pour 2 drops of phenolphthalein in there, which is the indicator that tells us when the acid is converting into base or the base is converting into neutral compound. And then in the burette, which is that tube at the top, that's where we pour our standard solution. Now, a super important thing to keep in mind here. If you have an acid in your flask at the bottom, you pour a base in the burette. If you have a base in your flask that you're trying to find the concentration of, then you pour an acid in the burette. In this case, we have sodium hydroxide in our flask. That's what we are trying to find the concentration of. So our standard solution, the one that we are pouring in the burette, has to be an acid, which is why it's hydrochloric acid. And then again, we can find the volume of the hydrochloric acid that we will use to titrate the solution by reading the volume from the burette. The burette has the volume readings. Okay, now once we have our solutions in the flask and also in the burette, we will put the flask underneath the burette and then we'll slowly start adding the solution from the burette into the flask. And we're going to make sure that we are swirling our flask constantly. Now, eventually, there will be a point when as soon as there is a drop of the solution from the burette falling into the flask, you notice a slight color change. But when you swirl it, that color change is gone. When you reach that point, you want to slow down the speed at which you are pouring the solution from the burette. Now you want to go drop by drop. Eventually, and notice, be very careful at this point, because after a while, after a few drops, there will be that one last drop that will pour into your flask, and the color change that occurs at that time will be permanent. It will stay. Stop pouring your solution at that point. This is your end point, because this is when you have a neutral solution. If you go beyond this, and if you continue pouring in the solution from the burette in the flask after this point, then you will not have a neutral solution anymore. And your titration would have failed. And you'll have to do all of that again. So The endpoint is a very tricky step in the titration experiment, but the key thing to do that correctly is to go slow and be very attentive and very careful. So once we have that endpoint, we will go ahead and read the volume of the standard solution that we have used. So of course, you will have to record the volume before you start pouring the solution, and then you record the volume after you stop pouring the solution. You'll subtract the two things, and that will give you the volume of the standard solution that we have used. So just a quick review about reading the burette, which is kind of the same as reading the volume of any solution in a graduated cylinder. The only difference is that in a graduated cylinder, the numbers go upward, so we start from the zero at the bottom, but in a burette, the numbers go downward. We have zero at the very top, and then as you go down, the numbers increase. So as always, you want to make sure that your eye level is with the bottom of the meniscus because that's where you read the volume. So the red line that you see there, that is the volume of the solution right now. And you want to read the volume to 0.01 milliliters, which means in this case, you will not read the volume of this solution to be 15.7 or 15.8. Instead, you'll read it 15.75 so that we have those two decimal places. Let's say this was your volume of the solution after you finished titrating. Before you started titrating or before you started pouring out the solution, your initial volume was 0.11 milliliters. That's what you read off from the bottom of the meniscus. So the final volume of this, let's say we have sodium hydroxide in this burette, the final volume of that sodium hydroxide that you have used in this case will be 15.75 minus 0.11, and that gives you 15.64 milliliters. Once we have our volume of the solution in the burette, the volume of the standard solution that we have used, we can go ahead and calculate the concentration of the solution that we have in the flask by using this equation given in table T. This is called the titration equation, and it reads as MAVA equals MBVB. Sometimes we'll also call it M1V1 equals M2V2. So if you see it the other way, instead of A and B, you see 1 and 2, that's still the same thing. They have just not specified that with an A for an acid and B for a base. So what these quantities mean is that the Ma is the molarity of the acid, or the molarity of the hydrogen ion. The Va is the volume of the acid. The Mb is the molarity of the base, and the Vb is the volume of the base. So let's look at this example of a titration experiment to see how we use that equation to find the molarity of an unknown and how we do the titration for this. The question is asking what is the molarity of hydrogen chloride, which is an acid, it's hydrochloric acid, if 10 milliliters of 4 molar sodium hydroxide, which is a base, neutralizes exactly 20 milliliters of hydrochloric acid. Now, the first step to set up a titration experiment for this is to pour 20 milliliters of our acid into the flask, and then pour a 4 molar sodium hydroxide solution in our burette. Next up, we titrate out 10 milliliters of the sodium hydroxide. Now in this case, it's a little bit different because the question has already given you the amount of the base that we'll be using to titrate this. But if let's say we are doing this in an actual lab, we don't know how much of sodium hydroxide is going to be used up. That's why we take care of that endpoint and we do it very carefully to make sure we don't miss it. And that's when we calculate the volume. But let's pretend that in this case, the question didn't tell us that we are using 10 milliliters of sodium hydroxide. So from the question, we know that we used 20 milliliters of the acid. That's the volume of acid. We do not know the molarity of the acid yet. That's what we are trying to find out. We do know the molarity of the base. We have a 4 molar solution. And we do know the volume of the base that we used because 22, which was the final volume of at the bottom of the meniscus, minus 12 milliliters, which was the initial volume of sodium hydroxide in the burette. That gives us 10 milliliters. Now let's put everything in this equation for titration. Here are all the numbers that we have so far. We are trying to find the molarity of the acid. We'll go ahead and plug that into the equation. The molarity of an acid is represented by an X. Now, if we want to solve for X, we want to bring the 20 milliliters on the other side. So if you want to get rid of it on this side and bring it to the other side, remember we can go ahead and divide the 20 milliliters on both sides. It will go ahead and cancel the 20 milliliters over here, and now we just have it on the other side. So when we do the math, that gives us 2.0 molar, and that is the molarity of the acid. Let's look at another example. This time, we are looking for the molarity of sodium hydroxide if 10 milliliters of 2 molar hydrogen bromide or hydrobromic acid neutralizes exactly 5 milliliters of sodium hydroxide. So first thing, because we want to find the molarity of sodium hydroxide, that's what we pour in our flask. How much of that do we pour? 5 milliliters. It's given in the question. In the burette, we pour 2 molar hydrobromic acid solution, and then we read off the initial volume from the burette to be 5 milliliters. We do our titration. Let's say again, the question didn't tell us that we use 10 milliliters. We are doing this ourselves. And then we do the titration. We look for the endpoint, and once the solution has changed the color, we stop it, and we record the final volume to be 15 milliliters. So now, here are all of our numbers. We have the volume of our base, which is 5 milliliters. We have the molarity of our acid, which is 2 molar. And we also know the volume of the acid that we used to titrate this. 15 minus 5, that gives us 10 milliliters. Now let's go ahead and plug everything into the equation for titration. These are all the numbers that we have so far. The molarity of the base is what we are trying to find out, so that's going to be our X. Now if we want to solve for X, we want to bring the 5 milliliter on the other side. So let's go ahead and divide the 5 milliliters on both sides so that it can get canceled out on this side, and now we only have it on the other side. Then we do the math, plug everything in the calculator, and we get the molarity of our base to be 4 molar. Now let's say we are doing this experiment in a lab. We will do 3 trials of the experiment, which means we'll follow the same titration procedure 3 times with the same acid and base. So we'll have our base in the flask at the bottom, and we'll have the acid in the burette. So let's say the concentration of acid that we are using in the burette is 0.5 molar. All right. And then for each of the 3 trials, the volume of the base that we'll pour in our flask is going to be 20 milliliters. So we have all of that information in this graph already. I mean, in this table. And now we are solving for the concentration of the base. So let's say when you do your first trial, you start pouring in the solution. Your initial volume of the acid in the burette is 0.10 milliliters. After you're done with the titration, you reach the end point. Your final volume was 3.12. Go ahead and calculate the amount used, or that would be the volume of the acid that you have used. And then use all of these numbers to calculate the concentration of the base for trial 1. For the second trial, we now start with the same volume where we left last time. So we were at 3.12 milliliters. That's going to be the initial volume for the second trial. And then we titrate the thing, and our final volume, once we reach the end point, is 6.25. Do the same thing. Calculate the volume of the acid used, calculate the concentration of the base using the MAVA equals MBVP equation. Then we do the third trial. We start with this volume where we left off last time, which was 6.25 milliliters. And then after we reached the end point, the final volume was 9.37 milliliters. Now do the calculation again. After you are done with the calculation for the 3 trials, you'll have the concentration of the base for trial 1, 2, and 3. Go ahead and take their average, and that is going to be the final answer or the final concentration of the base. Remember, how do we take the average? Just add all three of the concentrations of base that you get for trial 1, 2, and 3 and divide your answer by 3. And that would be the concentration of our base. Okay, and that was it for this unit. I'm going to peace out with that. Take care. I'll hopefully see you guys in the next one.